In the last video, we knew how to find missing sides given one angle and one side. Now we're going to find missing angles given two sides. So let's say you have a right triangle with, let's just say, you have two sides given to us, and let's say you want this to be 9 and this to be 12. And we want to find this angle right here, which will be theta basically here. So how will we find the missing angle? So we want to still remember this acronym, SOHCAHTOA. We do SOH for sine, opposite, hypotenuse. Okay, CAH. I'll just undo it. This will be H. Okay, Ka, basically, which will be cosine, adjacent, hypotenuse. And then you have TOA, which is tangent, opposite, adjacent. So you want to keep in mind, to find the missing sides, we actually used the sine theta equals the opposite divided by the hypotenuse. So we're going to use a similar thing here. So we want to use the sine formula. We have an opposite and we have an hypotenuse. So how can we write this? So we have sine of, let's say you have an angle here. The angle right here is going to be unknown. So we're just going to use theta. So in that case, it's going to be equivalent to the opposite, which is 9, divided by the hypotenuse, which is going to be 12. Now, how do you know where to go from here? So, you're not really used to solving trigonometric equations, but you're also going to get used to inverse trigonometry. So, you have sine, cosine, tangent, cosecant, secant, and tangent. So likewise, there's also inverse trig ratios. So let's say you have, let's just say, a sine, and then let's just say -1 of, let's just say, theta. This is how you express inverse trig. This is simply how you reverse. This is how you reverse taking the sine of something. In arc sine is how you reverse the sine of something. So this could also be written as arc sine. As cosine inverse can also be written as arc cos, and vice versa here. So what you want to do is take the inverse sine on both sides. So that's going to be theta equals, you got the inverse sine here. So we're going to do sine, which may seem like an exponent, -1, may seem like an exponent, but it's not actually here. And then you got 9/12. Now, you may be saying, can you simplify? Now you're saying, can you actually simplify what's going on inside the opposite over the hypotenuse? Well, let's use our calculator to find out. So we know the simplified form for 9/12 is going to be 3/4. So we can do inverse sine of, we got 9/12. The inverse sine of 9/12 will give us approximately, we got 0.8481 in terms of radians. And if we converted this to degrees, we would get 48.59. And we're going to label this with this circle here to symbolize degrees. Now let's say you did the same thing, but you did the simplified form, 3/4. In that case, you can actually simplify whatever's inside and still get the same results here when it comes to degrees. Now let's try with radians here. So we got inverse sine of 3/4. Yes, so you can actually simplify this to 3/4 here, and the angle will not change here. So that's basically how you do inverse trig. Now could you also do cosecant as well? So we got CSC theta. However, you want to keep in mind though that this is going to be 12/9 instead of 9/12, because cosecant is simply 1 divided by sine theta. If we did the inverse cosecant, which will basically be 1 divided by inverse sine, if you're using this on a calculator, then this will be 12/9. So as you see, inverse cosecant actually gives us a domain error. If we do 1 divided by sine 12/9. If we try to do that, if we try to take the inverse sine of 12/9, then we're simply gonna get a domain error. So therefore 9/12 is the way to go here if you do this here. So you're gonna want to rewrite it before doing this cosecant thing. So now let's try another triangle here. Assume the lines are straight and the side lengths are going to be 7 and 5, and you want to find this angle right here. Now how will you interpret this? So if you find this angle, you can actually go ahead and use the tangent formula here. So we're going to use tangent of theta will be equivalent to, now we want to know what the opposite is and the adjacent. So the opposite is going to be 7 and the adjacent is going to be 5. And the hypotenuse is the side that is opposite to the right angle. So that's how we know. So now we can simply solve for theta by taking the inverse tan. And once we do trig equations, we can see how this works. So we're going to do 0 equals, we got tan inverse of 7/5. And if we calculate this, we should be able to get, we get tangent inverse of 7 divided by 5. In radians, this will be 0.9505. And we simply put nothing here. because there's no other unit for radians here. We will see radians in terms of pi, but that's going to be for later here. So we got tangent of inverse of 7/5. In degrees, it's going to be 54.46 to something like that. So now we just want to solve for the missing angle. Now that we have 54.46. So in order to get the missing angle, we got 90 plus our new measurement, 54.46 plus we want our missing side, so I'll just put in a different color here. That will be equivalent to 180. And now we combine the like terms, so we got 90 plus 54.46. That's going to be 144.46 plus x is going to be equivalent to 180. And finally, to solve for x, we're going to subtract 144.46 on both sides. So that will leave x to be 180 minus 144.46 is going to be 35.54 degrees. So that's going to be this other measurement here. And I'll just put x here. And what about the side? I will put the side as c, basically, so we can solve it later on. So we can use one of our trig ratios to solve for the side, or we can just go simple and use the Pythagorean theorem. So let's use the Pythagorean theorem. So in this case, that would be a squared plus b squared equals c squared. So we got 7 squared plus 5 squared is going to be equivalent to c squared. And to solve for c, we want the square roots of 7 squared plus 5 squared. So we got 7 squared plus 5 squared under the square roots. And if you calculate this, you should be able to get 7 squared plus 5 squared under the square root should give us 8.6023 basically. And that's the missing side, and we found all the angles. So you can actually use angles to solve for missing sides. So if you have both angles missing, but if you have two sides, you can use the trig formulas to solve for both of the angles. So thank you all very much for watching. If you enjoyed, leave a like and subscribe, and we'll see you guys later. Goodbye.